Tableau was made with an intent to analyze data in a much easier and efficient way than we were doing all these years with these traditional methods. But if you have to start thinking about how to use the tool to solve a problem, the state of flow is broken. One common cause of this is the need to work with data that has been aggregated to different levels of detail. Hi, I'm Upasana from Edureka, and today we're going to talk about levels of detail in Tableau. Before we begin, let's look at the agenda for today. First up, we are going to talk a little bit about what LOD actually is, what it does. Then we'll talk about the various calculation in LOD, which are the include, the exclude, and the fixed calculation. Then we're going to talk a little bit about aggregation and LOD expressions, followed by nesting and inheritance in LOD. Then we're going to talk about the data sources supported by level of detail in Tableau. Finally, we have a short demo on how to create some simple LOD expressions in Tableau. Then we're going to talk about table calculations in LOD and finally discuss a few limitations of LOD. So without much ado, let's get straight into the module. Now there are a few questions which always arise while dealing with data that has been aggregated to intricate levels of details. And these questions are often simple to ask but really hard to answer. They sound something like, can I plot the number of days per quarter where my company had more than 100 orders? How can I find the biggest deal each salesperson has ever closed, then show the averages by manager? How can I tag every customer by the year he or she first became a customer and then use that tag to group the sales? In order to address these types of questions, Tableau 9.0 onwards introduced a new syntax called the level of detail. Now, this new syntax both simplifies and extends Tableau's calculation language by making it possible to address level of detail questions directly. So in simple terms, level of detail expressions represent an elegant and powerful way to answer questions involving multiple levels of granularity in a single visualization. Now, granularity and aggregations in LOD are inversely proportional to each other. How it works is, the more the level of granularity, the less is the level of aggregation, and vice versa. So here are the shelves which affect your LOD aggregates. You have your columns, rows, pretty much everything except for your pages and filter shelf. And these are the shelves which do not affect your LOD aggregates. These are your pages, filters, and tooltip. Now all these LOD expressions are segregated into three types. We have include, which basically calculates at a lower level of detail. We have fixed LOD expressions, which specify the exact level of detail. And we have the exclude level of detail expressions, which calculate at a higher level of detail. So first, let's talk a little bit about how you work a problem in level of detail. Now this map shows the restaurant inspection data from Yelp in the greater Edinburgh area. So the data in the view is aggregated based on the LOD, which in this case consists of city and state, and is more aggregated than the underlying data source. So the selected point in the image showed the average use of fans for all the restaurants in Newbridge, Edinburgh. Adding more granular dimensions to the view will result in a less aggregated LOD. For instance, we could add business ID to the visualization by dropping it on the detail shelf to see the average user fans for each individual business. By doing so, we'll also change the visualization. Every single business will appear as a circle on the map. But what if we don't want the visualization to change? What if we want to determine the total user fans for each business ID and average those values for each city and finally show only one circle per city? What we want to see is the average number of fans per restaurant in each city. Now this will require adding an additional dimension to the view without dragging that dimension into the visualization. A level of detail expression will allow us to do this. Now this expression tells Tableau to perform the aggregation for each business ID, regardless of other dimensions used in the LOD. You can use this expression to calculate the total user fans per business ID after dragging this new field into the view. We can then average those values per city. Now the fans per business field have been added to the color shelf, as you can see on your left. Now Newbridge has the highest average fans per business with 185 fans, a value that was computed using the fixed LOD expression. By using the fixed operator in our LOD expression, we gain insight into which cities have, on average, more fans per business ID, meaning those cities with a darker shade of blue have more popular restaurants, or maybe even the city could have more residents, and hence more total fans per restaurant. Now what you see up top is how the level of detail expression is structured. You have your scoping keyword, and then you have the dimension declaration, and finally the aggregate expression. So your scoping keyword as in your include, exclude or fixed, your dimension declaration, in this case your business ID, and your aggregate expression is what you want to do with that declaration. Like here, you are going to use some expression. Here is the structure given more clearly for the level of detail expression. Now, as a result of that, fans per business field have been added to the color shelf, and it shows that Newbridge has the highest, as computed using an LOD expression, average fans per business with 185 fans. Now let's talk a little bit about the include calculation. So the include LOD expression will add dimension to the LOD. The include keyword creates an expression that is less aggregated, which also means it is more granular than the LOD. The specified dimension are first added to the LOD before the calculations are performed. Now, notice that the include expression is used in the view as an aggregated measure. In fact, all include expressions are either used as measures or aggregated measures when placed on the view. Let's talk a little bit about the exclude calculation now. Exclude calculation basically means calculating at a higher level of detail. Using an exclude keyword will exclude the desired dimensions from the calculation. Tableau first removes the excluded dimension from the LOD and then performs the calculation as if the dimension was not present at all. The result is then displayed visually. The graphical representation of how Tableau performs an exclude LOD expression is depicted in the diagram that you can see. Next, let's talk about the fixed calculation. Now, LOD expressions also open the door to creating an aggregation level completely independent of the LOD, something that was previously only possible by the custom structured query language. Presenting to you, we have the fixed calculation, which basically specifies the exact level of detail. This LOD expression will fix the level of detail to each dimension and does the aggregation specified in the calculated field regardless of any dimension in the view. If you look at the sequence of filters in Tableau, fixed calculations are applied before dimension filters. So unless you promote the fields on your filter shelf to improve view performance with context filters, they will be ignored. Include and exclude level of detail expressions are considered after dimension filters. So if you want filters to apply to your fixed level of detail expression, but don't want to use context filters, consider rewriting them as include or exclude. Now let's go ahead and look at aggregations and level of detail. Now the level of detail of the view determines the number of marks in your view. So when you add a level of detail expression to the view, Tableau must reconcile two levels of detail, the one in the view and the one in your expression. The behavior of a level of detail expression in the view varies depending on whether the expression's level of detail is coarser, finer, or on the same level as the level of detail in the view. So what do we mean by coarser or finer in this case? So if I said the level of detail expression is coarser than the view level of detail, I mean that it references a subset of the dimensions of the view. For example, for a view that contained the dimensions category and segment, you could create a level of detail that uses only one of these dimensions. So when I use this expression here, the expression has a coarser level of detail than the view. It bases its values on one dimension, that is segment, whereas the view is basing its view on two dimensions, segment and category. The result is that using the level of detail expression in the view causes certain values to be replicated. That is, they will appear multiple times. Now, if I say the level of detail expression is finer than the view level of detail, it references a superset of dimensions in the view. When you use such an expression in the view, Tableau will aggregate results up to the view level. For example, the following level of detail expression references two dimensions. When this expression is used in a view that has only segment as its level of detail, the values must be aggregated. Here is what you would see if you drag the expression to a shelf. An aggregation in this case, average, is automatically assigned by Tableau, but you can always change the aggregation if you need it. Now, adding an LOD expression to the view. Whether a level of detail expression is aggregated or replicated in the view is determined by the expression type, which is fixed, include or exclude, and whether the expression's granularity is coarser or finer than the view's. Now, for include, the LOD will have either the same level of detail as the view or a finer level of detail than the view. Therefore, values will never be replicated. For fixed level of detail, expressions can have a finer level of detail than the view, a coarser level of detail, or the same level. The need to aggregate the results of a fixed level of detail depends on what dimensions are in the view. And finally, for exclude level of detail expressions, replicated values will always appear in the view as we had discussed before. When calculations include the exclude level of detail, Tableau defaults to the ATTR aggregation to indicate that the expression is not actually being aggregated and that changing the aggregation will have no effect on the view. Now let's discuss a little nesting in the level of detail. Now Tableau does not limit you to write single simple expressions. You can nest as many expressions as you want according to your requirements. So when you approach this kind of a problem, you'll have to understand a few rules that come with this inheritance property. So there are two types of inheritance in table calculation. One is the impact of fixed expression, which we had earlier mentioned, has impacts on where it is evaluated and which filters affect it. And then there is the dimensionality itself. So in this case, if you look at the first one, I am doing a fixed state and nested calculation. I'm saying include customer, so include, as you all know, inherits from its surroundings. If you build the dragging and dropping by itself, it will inherit from the parent calculation, so it will include the state. It will do the same things as writing state customer instead of it, and it won't be impacted by filters because the parent is a fixed calculation. With that, let's move on to the data sources that are supported by level of detail. So here I've made a list on data sources and whether they are supported or not supported by level of detail. Now let's move on to a hands-on of how to create level of detail expressions in Tableau. Now the question is how to create these LOD expressions. For that, we'll have to move on to our Tableau desktop. So let's head there. Now for your LOD expression, first up prerequisite is that you need to have a visualization already set up. I've created a very simple bar chart over here with regions from the dimensions data pane in the columns and sales in the rows shelf. Now step 2, instead of sum of all sales per region, which is given by Tableau by default, this one right here, perhaps you would also want to see the average sales per customer for each region. For this, you can use an LOD expression. So I'm going to go to analysis and create a calculated field. In this calculation editor that opens, I'm going to name this sales per customer. And then I'm going to put in this expression. So include customer name. And then I'm going to apply it to my visualization and click OK. So the newly created LOD expression is added to the data pane. As you can see, it's right here. Sales per customer under the measures pane. Now we are going to use this LOD expression in the visualization. So from the data pane under measures, I'm going to drag this sales per customer to the rows shelf and place it to the left of sum of sales. See right here. On the same row shelf, I'm going to right click on sales per customer and select the measure sum and then take the average. You can now see both the sum of all sales and the average sales per customer for each region. For example, you can see in the central region that the sales totaled approximately $500,000 with an average sale for each customer being approximately $800. Now this was all about the include expression. We're going to do the same for exclude and fixed. Now for exclude expression, we're basically going to try and exclude region from a calculation of sum of sales. And to illustrate how this expression might be useful, first consider the view that you see on your screens right now, which breaks out the sum of sales by region and by month. So I'm going to be creating this expression the same way I did before. You see a new measure being created here called exclude region. Now we're going to drop exclude region, this measure that I just showed you, on color shades, which is right here. We're basically showing the total sales by month, but without the regional component. I'm going to change the colors a little bit so it's more prominent. So let's go with this orange and blue divergent color. All right. So this is how the exclude expression is created. Now let's move on to the fixed expression, which is another sheet. Now, as I had mentioned before, a fixed level of detail expression computes a value using specified dimensions without reference to the dimensions in the view. So the fixed LOD expression I'm going to use now computes the sum of sales per region. So we're going to do the same thing, which is go to analysis and create a calculated field. As you can see, this measure has been created here. So what I'm going to do right now is I'm going to take this measure and place it on the text to show the total sales per region. So the view level of detail is region plus state. But because fixed level of detail expressions do not consider the view level of detail, the calculation only uses the dimension that is referenced, which in this case is region. Because of this, you can see that the values for individual states in each region are identical. With that, let's switch back to our presentation. This is a very common question of how the level of detail compares to the table calculation. And now that we have level of detail, do we actually need table calculations? The answer is yes, you will still be needing table calculations, but the LOD is here to take care of a lot more other things. Now, first of all, table calculations are generated by query results, whereas the LOD expressions are generated as a part of query to underlying data source. The table calculations can produce results either equal to or less granular than said LOD. Dimensions that control the operations of a table are separate from calculation syntax in table calculations, whereas in LOD expressions, dimensions that control the operations of an LOD expression are embedded in the expression itself. Another big difference is table calculation can be used as aggregated measures, and LOD expressions can be doubled for various other constructs. The filters on the table calculation act as a hide, whereas filters on the LOD act as an exclude. And finally, let's discuss the limitations of level of detail. Now, there are a few limitations and constraints that apply for the level of detail expressions. Now, level of detail expressions that reference floating point measures can behave unreliably when used in a view that requires comparison of the values in the expression. The LOD expressions are not shown on the data source page. While referencing a parameter in a dimensionality declaration, we cannot use parameter values. We have to always use the parameter name. So if you do not know the parameter name, then you're going to face a problem with dimensionality declaration. And finally, with data blending, the linking field from the primary data source must be in view before you can use a level of detail expression from the secondary data source. In addition, some data sources have complexity limits, and Tableau will not disable calculations for these databases. But query errors are a possibility if calculations become too complex. With that being said, LOD expressions are a powerful new capability of Tableau which allow us to easily solve problems that previously required very complicated formulae. They allow us to intuitively define the scope of calculations and stay in the state of flow as we explore our data. They are not a new form of table calculations, even if they can replace many of them, but they do open doors to new possibilities. Contrary to popular belief, LODs and table calculations operate very differently from each other. And finally, I'd like to say that LOD expressions represent a vital step towards the goal of complete flow, where all questions are simple and elegant to answer. With that, I conclude my session. Thank you and have a great day ahead.